I don't
You
know.
can just accept it or
I
not.
haven't read anything.
What is it? Did you understand what he was saying?
Are we supposed to just determine like now we just determine the essentially like revolutions per second for the axis?
Oh my god.
Is that what we're supposed to do?
I
hate this.
I don't.
Oh, we have 6 more days after today.
Oh my
of
God.
class.
So is our answer gonna be in like radians or some crap?
Oh.
I think he was going somewhere. I don't know why I stopped him.
I got lost as soon as we finished that.
Yeah, I followed it to there and then I got confused again.
Alright. So, diameter of the pulley, which I actually have done all this in another video. Diameter of the pulley is shifted on me. Usually these things are so stuck, this one's rather loose. $50. 51.05 millimeters. And of the axle, diameter of the axle, and crude estimate is 6.30 millimeters. I assume that was the sound and the look of relief because now it is all so clear.
I feel a little bit like I'm in the Twilight Zone and this is actually a trick question. And I'm overcomplicating it.
It's not meant to be a trick question.
Okay. You're not gonna jump out at any given point and tell us that we've been pumped?
No,
Okay.
I haven't so far. With other classes that I've done.
So now we can determine.
Give it your best shot. I mean, I have the way that I would go about it, and which I've laid out pretty much here, but there's a wide variety of answers that are good enough.
How many points would we get knocked off if we got the wrong average friction?
Well, since I wasn't measuring friction, I don't know what the right value was. If your approach was completely ludicrous, and you throw a dartboard with numbers on it and go, that's my friction, you'd probably get no points. If you went through some reasonable approach, it'd be a minor deduction. You could leave it blank, you lose 7 points. Out of 6.
So, after we turn in the lab, will you tell us what we were supposed to do?
There's not a what you were supposed to do. Didn't I say reasonable approach?
It does, but
What does it mean by reasonable approach?
I can show you the way that I would do it, but that's not necessarily the right way.
okay.
Yes?
So at this point, given the diameter of the pulley and the diameter of the axis, would we have to determine the length of, we would determine the H already measured. And the time, how many rotations it took based on.
Yeah, it's actually also proportional.
Okay,
So if you have a ratio of diameters, if you know what H is, which is how far a point on the outer part of the wheel moved, it would be proportional to how far on the inner part. Is that a handout?
Yeah.
Okay, yes.
Are we still staying on this topic or can I ask something?
Ask away, move on.
Is everybody okay? Okay. So we're not gonna get our final grade until after 10th.
Right.
I just think
Is
that.
anyone getting a final grade till after the 10th? Before the 10th?
No, but I was wondering if you could get at least what grade we're on before the test, like without the test 3 and 4.
I will do my best.
I just think it would be fair for all of us. Because I don't
See,
want.
here's the, I understand, and in your position, I would be wondering too, but it really makes it seem like it's all about the grade, not the knowledge. And that's the part that sort of disturbs me. But I understand it, I've been there too.
I know it can get disturbing, but it's important for my life, in my life to, get a good grade on this class,
Okay.
to be successful. I know that's what you want for all of us.
Yes, I want everyone to be successful. Because they understand the material.
What would be the cutoff between a B plus and an A minus? Is it 3.5?
By strict interpretation. There's leeway. There's a mystery box that all the grades get dumped into, and out comes some number, which I did have to interpret. If somebody gets a 3.49 and someone gets a 3.5, does there really any difference? Well, the difference probably could have come down to my mood when I graded each of their some assignment, which got them off by 1/100th of a point. I can't differentiate between a 3.49 and a 3.5. So therefore, if you got a 3.49, that's probably an A. So at what point do I do a cutoff? If I have every grade from a 3.00 to a 3.50, well, at some point there is a difference between the grades. And, I just have to make the call about where that cutoff is. However, speaking of content, let's talk about cross products. So we talked yesterday about the fact that cross products, you're multiplying perpendicular components. We also talked about how to do a cross product if I give it to you in polar form and how to determine the direction of a cross product. So first off, let's make I hat to the right, J hat up. In a right-handed coordinate system, I hat cross J hat equals K hat. I am assuming a right-handed coordinate system. If you want to go outside of the right-handed coordinate system, you would have to describe that you're doing it that way. So what I mean by that is, if I do I cross J, again, I put my hand in the direction of the first vector, to the right. I have 360 degrees of freedom, in theory. I want my fingers so that they curl towards the other vector. So I have I hat this way, J hat is up, so put my hand palm up, so my fingers would curl towards J. My thumb points in the direction of the cross product. So I hat cross J hat is K hat, which is coming out of the board. Now, how do you represent something coming out of the board?
coming out of the board, no. However, that's the answer to the other question of how do you represent something going into the board.
Oh.
So for something going into the board, you do a cross. For something coming out of the board, into, out of, it's a dot. And the general memory trick is if an arrow is coming toward you, you see the point. If the arrow is going away from you, you see the feathers.
Wow.
So I would write this as I hat, J hat in a right-handed coordinate system. K hat's coming out, so I do a dot, and then write K hat. If I did J hat cross K hat, which way is that pointing? J hat cross K hat. You put your hand in the direction of the first vector, so your finger scrolls through the next vector. J hat's pointing up, K hat's coming out.
Top right.
You said, say it again?
Is it going?
To the right.
We have to the right.
Is it coming out of the board to like an angle?
No, it's gonna, when you do a cross product, whatever the cross product is, or whatever the answer is, it is perpendicular to the other two vectors.
So like it'll be between the I hat and the K hat, but
So if J hat's pointing up, so my hand points upwards, K hat's coming out of the board, so I want my fingers to curl towards it. My thumb points to your right. So J hat cross K hat,
Wait, can you do that once more?
so you put your hand in the direction of the first vector, the J hat, so that my hand is pointing up, because J hat's pointing up. K hat's coming out of the board, so I want my fingers to curl in that direction. My thumb points in the direction of the product. You went the other direction. Hand points up, J hat's going that way.
I'm imitating you, sorry.
Okay,
I think I was just following along.
so J cross K points that direction, which is I hat. If I did I cross K,
start with I hat.
so therefore Pratika,
Down.
which would be
Negative J hat.
yes. I hat cross K hat, negative J hat. So I hat pointing this way, K hat's going out. So finger points that way, I want my fingers to curl towards the second vector, thumb points down. Now, on our test or quiz, you're trying to figure out I hat, J hat, K hat, and which ones is crosses, which ones. Yeah, you can go through this exercise, that should work. Or, if I go in alphabetical order, I, J, K. If I'm going that direction, it's positive. So I cross J is K, J cross K is I can just write it again if I need to. J cross K is I, K cross I is J. If we go in the other direction, it's negative. J cross I is negative K, I cross K is negative J, K cross J is negative I.
Okay. That's interesting.
Obviously, the commutative property of multiplication does not hold here like it does with dot products. The order does matter.
In the two that you did where we, did the whole.
Yep.
K and all of those would, it would literally just be the same, it would be the dot.
Yeah, it's a
Like, if
vector
you were to
coming out of the
draw
board.
it, Yeah.
Yes?
So is this rule the same thing as how we did with the door
Yes,
yesterday?
it all works together.
But we did the thumb first yesterday.
That because when you're dealing with rotational motion, you do have the advantage of being able to come up with a pivot point and knowing which way something's gonna turn. That's just, it was convenient in that case.
Okay. It's the same rule though,
It is ultimately the same rule.
but the steps are jumbled.
Pardon?
But the steps are jumbled, cause we did the thumb first
Oh,
and.
yes,
Okay.
yes. So if I'm doing A cross B here, I have 4 I hat plus 3 J hat cross -2 I hat minus 4 J hat. Well, foil. So I have 4 I hat cross -2 I hat, or -8 I hat cross I hat. Outer minus 16 I hat cross J hat. Inner minus 6 J hat cross I hat. And then last minus 12 J hat cross J hat. Now, if I have them perpendicular to each other like I do over there, I mean I hat cross J hat is K hat. J hat cross I hat is negative K hat. But what about I cross I or J cross J? What is any vector with a cross product with itself?
Zero.
Say it again?
Zero.
Yeah, cross product multiplies perpendicular and every vector is parallel with itself. So that's 0, that's 0. And you end up with -16 K hat plus 6 K hat, and you end up with -10 K hat. So if I'm in rectangular form, I would do it this way. I wouldn't write down the I hat cross I hat and J hat cross J hat because I know there's 0, those terms are gonna drop off. But nothing wrong with it, just so long as you get rid of it at some point. If I'm in polar form, so let's say I've got 5 at 37 degrees, cross 6 at 140 degrees. Well, first I'd sketch it out. 5 at 37 degrees, I guess something like that. The other one's 140 degrees. Not to scale. That's 140 degrees. That's 6, that's 5. What is the direction of the cross product gonna be? We're gonna do direction separate from the magnitude. What is the direction of this cross product? You put your hand in the direction of the first vector, so your fingers curl the fastest way to the second vector.
Oh.
Towards
Okay, hand direction, assuming that definition over there. So I know that the direction will be k hats coming out at us. And in terms of the magnitude, well, I'm multiplying perpendicular components, so I would break this up into vectors and I would figure out what that is. Now, it might look very complicated here, but in essence, it's the sine of the angle between them. And so the magnitude is going to be 30 times the sine of the different angle between them, which is 103 degrees.
Wait, 30 is just multiplying them?
So it's just, you multiply the magnitudes times the sine of whatever the angle is between them. With the dot product, you'd multiply the magnitudes times the cosine of the angle between them.
Angle between them, meaning the difference?
The angle, yes,
Okay.
How do we know when to use the dot product or the cross product? Because when you gave us that example, the first thing that popped in my head was just the resultant from the tip of 5 to the tip of 6. Just like a straight line across, not like a dot product. Like I only knew like it had to go to.
if you do something from head to head,
Yeah.
I don't know any physical meaning that has, or math meaning really.
But like, how would we know that we have to use a cross product to solve the question?
If you're dealing with torque and rotational motion, probably gonna be doing a cross product. If you're doing work and energy, probably gonna be doing dot product. It's gonna be based on whatever formula you happen to be using. I feel like that was not a satisfying answer for you.
Like, because for the test there could be like a warm up just telling us to find like the magnitude of like these vectors, but I wouldn't know which process I should use, like the cross or the dot product, you know? Like for the first test we had like find the resultant vector for this, so I just used a dot product for that. But for the next test, if we had like a warm up question like this, how should I know that I have to use a cross or a dot? Would you just tell us?
If I said, well, I've done ones in the past where I've said, where I've given the equation and asked you to find it, and I had a cross there, meaning cross product, and or I put a dot there, meaning you're doing a dot product. I mean, there's, could be as simple as that. If I gave you a force